Hi, good morning, everyone. So, uh, I hope all are doing good. So, today we have a webinar on our things HiFi Gutta inverters applications, their export applications. Okay, so uh, as you know, like ThingsCloud is a tech company which is based in Bangalore. So we started in 2015, and we were developing the solar grid inverters and hybrid inverters. And by 2017, we have come up with the product, and we have did all the MNRE certifications, and we started supplying to the customers since 2017. And we have three variants of products like 1, 3, and 5 kVA, both grid tie and grid hybrid. So today here we are discussing more about the zero export applications. How the system is how is the system and how it is going to mean benefit to the end customers. So that is the main topic we are discussing about here. So this is just an introduction. And this is our team. So Mr. Amrut, he founded Mr. Amrut and Anishil. They founded this Physical Technologies. Both are technical, techno people, and they are like uh, they had they were working in US for this prominent companies, and they were doing and after that they have come to India, and they were working with other renewable energy companies. And it is with those experience, and they have started things cloud, and started making this grid tie inverters. Probably we are the first one who have things say grid tie inverters in India. And myself Vasudevan, I'm leading the sales, and Mr. Rohan is the growth head. So this is our product chain. So basically, we are in different sectors like solar, battery based. Like when it comes to hybrids, so battery based systems, and grid, and Wi-Fi. So Wi-Fi is for remote monitoring, and cloud is where the data is stored and we are processing it. And mobile is for the applications where you can monitor the system. And our presence. So we have the R&D Center here in Kalyanagar, Bangalore, and manufacturing unit in Whitefield. That's also in Bangalore. And this is a glimpse of our R&D Center, which is there in Kalyanagar. And this is our production line. This is just glimpse of our production. And this is a good factor. So this is a few of our installations with our inverters. And when it as I informed, like I explained earlier, like we have three, two types of products. One is a grid tie and grid hybrid. So grid tie is nothing but it will convert the DC into AC, and it will feed to the grid. So whatever the generation is there, it will feed to the grid with the help of a bidirectional meter, and whatever the like say you have used some 200 units and you generated 120 units and sent to the grid, then we have to, yeah, like we have to pay for this 80 units. So that is how the grid tie system works. And grid hybrid is nothing but a grid tie inverters with a battery backup. So whenever, so usually this grid tie inverters, it will not generate power in the absence of power. If the grid is not available, will happen, it will not get the reference voltage and it will not generate any power. So whereas when it comes to hybrid systems, it will be, there's a battery bank, so it will act as a reference, and whatever the, even though the grid is not available, it will generate the power and it will feed to the load which is connected to the inverter. So so it is like like in a UPS, so grid tie inverter with a UPS facility. And Things Wi-Fi is nothing but a IoT device which will helps to do the remote monitoring. So whatever the data which is showing in the display of the inverter, and whatever the data is stored in the inverter, it will be pushed to the cloud. So whereas we can excuse me, we can process the data, and we can see the graphs, what is going on in the site, and what is the generation, the daily generation, and monthly generation, yearly generation, all the you it in the our. So Things IO is nothing but a app which helps to monitor the, the monitor the site through our mobile app. And we have a web dashboard as well, so where you can see all the details in one dashboard. And Things HiFi. So this is our grid tie inverter. So we have, these all single phase inverters of variants, like we have three variants, 1, 3, and 5 kVA. And this is a high frequency model, that means a transformerless model, and it's with the built-in AI. Built-in AI is nothing but boost algorithm which helps to, in case of any so like partial shadow or something, so we can ensure that we are getting the maximum output from the solar. So that is what this AI helps. And this zero export device is an optional. So those who wants the zero export, so they have to priorly inform us, so we can, we can make it. It will be like in a built-in. So that is an optional. So, and when it comes to, and the other thing is the built-in load sharing algorithm. So built-in load sharing algorithm is nothing but, if the solar is available and you have a load which is running, so it will share among the solar and the grid. And cloud-based monitoring. Cloud-based monitoring is nothing but, with the help of Things Wi-Fi. So whatever the data which is there in the inverter will push to the cloud, and we can monitor through the app or web dashboard. And as we are using all high quality components, and this prominent components, and we could achieve more than 9, and with the help of our algorithm, the MPPT algorithm, we could achieve more than 99.5 percentage of MPPT efficiency. And the next version of our inverters, it can handle bifacial panel as well. So the next era is with bifacial panels. So for the, the space constraint and the efficiency. So usually this how the normal system works. So So here is the solar panel which is connected to the DC-DB, and from the DC-DB there's a things HiFi inverter. So this is our inverter. So whatever the variable DC which comes to the inverter, it will regulate, then it will convert into AC and push to the grid. So here there will be energy meter. So this is for the explanation sake of uh, I have drawn here. So it is nothing but how much energy is being generated. So normally, like our inverter is having that inbuilt. So no need to connect this in energy meter in an actual installation. And this is how the AGDB, and from there there's a home which all the loads are there. So whatever, if there is a load, it will it will utilize here. Otherwise, whatever the data, whatever the energy is generated will be pushed back to the grid through a bidirectional energy meter. So if you look at here, so the arrows are like these are all single directional, and here is the bidirectional. So whereas like if the consumption is more or demand is more, then it will take from the grid as well. And these are the certifications we have. So all required certifications we have for this products. And zero export. So the first application we can say is like zero export. So zero export is nothing but if like the grid tie inverters are meant to feed whatever the generated energy to the grid, right? So here we are restricting the inverter not to send back to the grid, and whatever the generation is there will be utilized in the local network. That means if it is a, we can say, so if it is connected to a home, then the local network is nothing but the whatever the loads which is there in the home, right? So the main advantage is like so there are some places like many districts, many states, they are struggling to get the net meter, right, bidirectional meter. So and it is like it is a pain point for the integrator as well as to the end customers. So that is how we thought of, okay, we'll do it with the inbuilt with the inverters, so no need to apply for the bidirectional energy meter, and they can save almost 10 to 15,000. Even though if it is a 1 kilowatt system, they have to spend on almost 10 to 15,000 rupees for the bidirectional meter. All the expenses together, right? And so this is a main pain point, the both the end customer as well as the customers. Whereas I've seen many sites where they have installed the site, and for this, even though even after completing 6 months, they haven't used even a single unit from the solar. Excuse me. So that is a main pain point for the customer. So that is how to solve that issue. So we have come up with this solution, and this is mainly for wherever the issue with the net meter or approval. Okay, so they can go for this zero export systems. Main and other advantage is like to come down, like to bring down the slab rates. Like say if you for 100 up to 100 units there will be a slab, and 200 units there will be there will be a different rate, and more than 200 it will be like higher rate. So to bring down the slab rate, so we can utilize this, like say if you are using 300 or 400 units and connecting one 1 kilowatt zero export system, and we can bring down to 280, like say 400 units they were using, they were consuming, so we can bring down to 120. So they can avoid that the higher tariff rates. So it will make a lot of impact on their current bills, and the ROI also, it will be it is much better compared to the normal systems. So if you take domestic users in Karnataka, so up to 30 units they have to pay 3.75 3 rupees 75 paise per unit, and up to 100 units and 30 to 100 units it is 5.20, and 6.75 for the 100 to 200, and 7.8 for the rest. So if say there is a customer who have two like a 220 units 220 units of consumption, and by connecting a 1 kilowatt zero export system they can bring down to 100. So they have to pay up to 6 point up to 5.20. No need to pay the the 6.75 and 7.8 after 300 units. So that is the advantage. And wherever this educational institutes or commercial spaces where they have a day like a daily, I mean the day consumption is more, and they have a consistent loads in the daytime. So like clinics, shops, and beauty parlors, labs. So wherever, and petrol bunks or wherever, like they have a daytime load, so they can go for this system. So don't need to break their head on getting zero, I mean the net meter and all. And so hence we are providing this system to bring down the current bill. And also the and also we can reduce the current, I mean the diesel consumption on the diesel generator. But it for a bigger diesel generator it won't make any sense. For a smaller systems it makes sense. So how this system works? So there is a small change in the connection. Like normal grid tie inverters, it has only one port where you can have AC connection. But here it is two ports will be there. One is AC in and other one is AC out. So AC in is nothing but we are connecting from the energy meter to the inverter, and AC out to the ACDB. So if you look at here, so AC in will be here, and AC out will be connected to the ACDB. So whatever the energy is being generated, it will be pushed to the load. If there is no load, then what will happen? If it will sense that, and it will ensure that you are not sending even a single unit to back to the grid, and it will just our MPPT algorithm will stop the generation. So I'll just explain you like how the system, like different three different conditions which we come across. So I'll just explain all this. So this will be the connection diagram. Like there is a solar panel and the junction box, and we are connecting to the AC, I mean DCDB, and we are connecting to the uh, inverter, and there is a AC in where we are connecting to the grid through energy meter, and this is AC out to the ACDB or load, and there will be IoT for the monitoring purpose, right? So as I said, I mean we'll go through some different conditions for we come across. So the first condition is like the we have a load of 800 watts, and our solar is generating 800 watts. So whatever be generated will feed to the load. So there is no export or limits happening. And if you look at here,